Okay, let's take a look at these exit problems. Number one, according to the National Health Statistics reports, a sample of 360 one-year-old baby boys in the United States had a mean weight of 25.5 pounds. Assume that the population standard deviation is sigma is equal to 5.3 pounds, and let's construct a 95% confidence interval for the mean weight of all one-year-old baby boys in the US. Okay, so looking at what we have in this problem, we have a sample size, we have a sample mean, and we have a population standard deviation. So the fact that you're given a population standard deviation of sigma tells us that the proper tool in the calculator to find the 95% confidence interval will be z-interval. So let's pull up the z-interval tool in the calculator right now. Okay, so we press stat, we go over to test, and z-interval is number 7. We put it on stats because that's what we have here, is we have the stats. And sigma is 5.3. X bar, the sample mean, is 25.5. And then n, the sample size, is 360. We want to create a 95% confidence interval, so we can either put in 95 or 0.95, and then we get our answer of 24.953 up to 26.047. Okay, so we interpret that as the population mean weight of all one-year-old baby boys in the United States is likely to be in that interval, and we have 95% confidence in that. Okay, so part B, based upon the confidence interval in part A, is it likely that the mean weight of all one-year-old boys is less than 28 pounds? Well, the answer to that question is going to be yes, it is likely. And the reason the answer is yes is because when we look at this, the mean weight of all one-year-old baby boys is likely to be between 24.953 and 26.047. So the population mean, even though we don't know exactly what it is, it's somewhere in this interval, and no matter where it is in that interval, it's going to be less than 28 pounds. So the answer to that question is most definitely a yes. Okay, now let's take a look at question number 2. So in question number 2, it says, in a sample of 123 hip surgeries of a certain type, the average surgery time was 136.9 minutes, with a standard deviation of 22.6 minutes. Now, something worth noting in this example is when we're given the stats, all of the stats are in reference to the sample. So the sample size is 123, the sample mean is 136.9, but the standard deviation here of 22.6 is also a sample standard deviation. Notice that we also do not see the sigma symbol. And so when we construct a 95% confidence interval to estimate the mean surgery time for the procedure, we are going to go to the t-interval tool. So let's go into the calculator this time and use t-interval. Okay, so again, we go back to stat, test, t-interval is number 8. And again, we're on stats, and we are going to enter a sample mean of 136.9. And S is the sample standard deviation, 22.6. And N, like we've seen throughout this entire course, is the sample size. So we put that in as 123. Once again, we're doing a 95% confidence interval, so we can just press calculate. And we get a confidence interval of 132.87 up to 140.93. Okay, so let's go to part B. In part B, it says if a 99% confidence interval were constructed with these data, would it be wider or narrower than the interval constructed in part A? So a couple ways to think about this. One way is just to quite literally think about it and recognize that if you're going to have a greater level of confidence that your true population mean is inside an interval, the only way that that can happen is if the confidence interval is going to be wider. And again, it's just because if you're going to be more confident that your population mean is in an interval, then the only way that you can be more confident is if that interval is bigger or wider. But we can confirm this with the graphing calculator. So let's go back into stat tests, and I'm going to go down to t-interval, and I'm just going to change my confidence level to 0.99, and you calculate, and you can see this time your interval changes to 131.57 up to 142.23. So this is the confirmation that goes along with our thinking, right? So we were thinking that the interval is going to get wider, and now it's confirmed by the calculator. So the answer to this question would be our confidence interval would be wider. Okay, let's take a look at part C. So in part C, we're estimating the sample size needed so that our 99% confidence interval will have a margin of error equal to 4. And remember, this is the problem where we need to rely on the following formula. The necessary sample size is going to be found by doing Z alpha divided by 2 multiplied by S divided by M, and then we're going to square that result. So let's list what we actually have going into this problem at this point. So we already know that S is equal to 22.6 in our problem. That's our sample standard deviation. We also know that M, our margin of error that we want to have, is 4. And we're looking for N. So the big thing here is we're trying to find this Z alpha divided by 2. And remember, there's a process that we go through to find Z alpha divided by 2. The very first thing that we did when we went through this process before is we would set 1 minus alpha equal to our confidence level. And so if you had $1, how much are you taking off of that dollar to get 99 cents? We could reason here that alpha would need to be equal to 0.01. So we solve 1 minus alpha equals 0.99 for alpha to get alpha is equal to 0.01. The second step is we take our alpha and we divide it by 2. And that leads us to 0.01 divided by 2, which is just 0.005. Okay. Step 3 is we go through and we find the Z of alpha divided by 2, which again in this case is going to be Z sub 0.005. So that's the Z-score in a standard normal distribution that has an area to the right of 0.005. So we're looking for the Z-score, and the area to the right of our Z-score is 0.005. If the area to the right of our Z-score is 0.005, then the area to the left, which is what we need to be able to enter into the calculator, the area to the left is going to be 1 minus 0.005. And when you do 1 minus 0.005, you end up getting 0.995. So this area to the left of our Z-score of interest is this 0.995. We go into inverse norm in the calculator, and we enter in 0.995 with a mean of 0 and a standard deviation of 1. So let's do this. Second vars into inverse norm, 0.995, mean of 0, standard deviation 1, because we're working with the standard normal distribution. The default is always left, and as we have selected here, the tail is on left. We paste that in, and we get a Z-score, our Z alpha divided by 2, that is equal to this 2.5758, etc. But remember, the big advantage that we have is this is built into the calculator. We don't have to round it at all. Let's just take the Z alpha divided by 2, multiply it by our S. So I'm going to multiply my answer by 22.6, divide by the margin of error, which is 4. So I just found the quantity inside the parentheses, and then I'm going to square the whole thing. And you can see that we end up getting an answer of 211.8, and when you take 211.8 and you round to the next whole number, the answer to our problem is going to be 212. And I encourage you with these problems to go back into t-interval and check your answer, see if this actually works out. So if you go into t-interval, we already have our sample mean or sample standard deviation in there. Let's increase that sample size to 212 with our 99% confidence interval. And you could see here that our the mean of our interval, 136.9, is approximately 4 away from each endpoint. If you added 4 to 136.9, you would be at 140.9, which is basically what you're at. And if you went 4 in the opposite direction, you'd be at 132.9. So again, this particular sample size allows us to achieve a confidence interval with a specific margin of error. Okay, last example, number 3. Sleep apnea is a disorder in which there are pauses in breathing during sleep. People with this condition must wake up frequently to breathe. In a sample of 427 people aged 65 and over, 104 of those 427 have sleep apnea. So a point estimate for the population proportion of those aged 65 and over who have sleep apnea would be the 104 out of 427. And so you can express this answer, you can express your answer there as a fraction, or we can certainly enter it in as a decimal. 104 divided by 427 is equal to 0.2436 if we're going to 4 decimal places, 0.2436. Okay. Also, we call it a point estimate, but a lot of times we denote it with p hat because that's our sample proportion. And what we're going to do is we're going to use that sample proportion to construct this 99% confidence interval for the true population proportion of those aged 65 and over who have sleep apnea. So we're computing a confidence interval. We're working with proportions now. That's going to take us to our confidence interval tool, 1 prop z int. And you might recall that x is the smaller of the two numbers between x and n. X is the number of people that are meeting a certain characteristic out of n, which is the sample size. So in this case, we have 104 people with sleep apnea out of 427. Our confidence level is a 99% confidence level, so we could just leave that at 0.99, and we can calculate, and we end up getting a confidence interval of 0.19005 up to 0.29706. So the true population proportion of those aged 65 and older with sleep apnea is somewhere between about 19% and 30%. Okay, so let's take a look at this last question now. In another study, medical researchers concluded that more than 9% of elderly people have sleep apnea. Based upon the confidence interval, does it appear that more than 9% of people aged 65 and over have sleep apnea? Well, the confidence interval tells us that somewhere between 19 and 29.7%, almost 30% of adults 65 and over have sleep apnea. So we don't know exactly what that true population proportion is, but we're 99% confident that it's between 19% and almost 30%. So if the claim is that more than 9% of elderly people have sleep apnea, then we would say our confidence interval certainly supports that claim. So that when the question says, based upon the interval, does it appear that more than 9% of people have sleep apnea? You would say absolutely yes. And if you were to explain this out in more detail, you would just say yes, the true population proportion is somewhere between 19 and almost 30%. Thanks for checking out these examples. I hope they help.